Alright, so we are in day 2 of Unit 8, and this is about factoring. Factoring polynomials. Hopefully most of this factoring will be a review from your Algebra 2. So let's go ahead and get started. So this is just a graphic organizer kind of telling you what steps to take, when to take them. So the very first thing that you do, we're going to put right here. And then after that happens, you decide how many terms the polynomial has. You can have 2 terms, 3 terms, or 4 terms. And then based on that, what you'll do from there. Okay? So, the very first thing you should always look out for, I'm not guaranteeing that it's going to be in there, but there might be a greatest common factor. So GCF, greatest common factor. So for example, so I'll try to do an example next to each one. So for example, if we have 2x cubed plus 6x. So if I'm asking you to factor this equation, so greatest common factor is when all your terms, in this case just the 2 terms, but when your terms have something in common, and you want to go as much as they have in common as possible. So if you look at the coefficients, they both divide by 2, so they have a 2 in common, and they both have an x. So 2x, that's considered the greatest common factor. And then you open parenthesis, and it's kind of like distribution. 2x times what is 2x cubed. So we need an x squared here. And then 2x times what gets you 6x. So you already have the x, but you do need the 3. X squared plus 3. Okay? And if you could go on, you would, but this is as factored as it gets. So that's an example of only greatest common factoring. Now, that's not the only step that you do. Sometimes you might have to go on. And sometimes you don't have a greatest common factor. So this is what you look out for first, and then you either do it or don't do it, but then you go on. Does it have 2 terms, 3 terms, or 4 terms? So let's do the 3 terms first, because it's probably the most common, or at least the most familiar. So if it has 3 terms, the step that we're going to call this is called factor by grouping. So factor by grouping. So my example here, we will do an example here. So if you have 2x squared plus plus 7x minus 15. Okay, so let me bring this over here. So this is our example. You have some steps to take. So your first step is to multiply a times c. And after you multiply a times c, find your factors that add to b. Okay, so let's do that. Multiply a times c. So remember, it's ax squared plus bx plus c. So 2 times negative 15 is negative 30. And we want to find 2 numbers that multiply to 30 that will add to 7. So if you just want to list them all off, you can do that. 1 and 30, 2 and 15, 3 and 10. 4, we got to skip 5 and 6, and then you go to 6 and 5, which you're really starting to repeat yourself. So 1 and 30, can that add to 7? No, it can't. 2 and 15. No, it can't. 3 and 10. Yes. How? So if you use a positive 10 and a negative 3, that will add to 7. Okay, so that's your step 1. Step 2, rewrite with split b. So what I mean by that is, remember, we're choosing negative 3 and 10. So instead of writing 7x, you're going to write negative 3x plus 10x. Okay? So you're writing 7x in a way that's splitting it up. So negative 3x plus 10x, that is 7x. You're just writing it a little bit different. Okay, so you still have 2x squared. We're not changing that, and we're not changing minus 15. All right, step 3. This is where you really start factor by grouping. Group. So group and group. Step 4, pull out. So from your first group, the numbers don't have anything in common, but they do both contain an x. And we're left with 2x minus 3. And in the second group, they both divide by 5. Since this is a plus, you're going to use plus 5, 2x minus 3. Okay? Now, I'm going to do in parentheses right here. This is your mental check, or your quick check, because these two parentheses should always match. So 2x minus 3, 2x minus 3. They match. Everything you've done so far is correct. So then your answer is just x plus 5. So I wrote what's outside the parentheses. It doesn't matter the order, but I wrote x plus 5. And then 2x minus 3. Okay, and that's it. Alright, so that's what we would do for if we have 3 terms. Now if we have 4 terms, it is also factor by grouping. So I'm not going to write these steps again because you're going to see how similar it is. So we have 4 terms. It would look something like this. So 5x cubed minus 10x squared plus 2x minus 4. So this is 4 terms because you have 1, 2, 3, 4 terms now. So it's actually going to be really similar to the other factor by grouping, except this time you already have those 4 terms, so you kind of start on step 3, where you start automatically with those parentheses, because you already have the 2 pairs. Okay, and then from here, same thing. So 5x squared gets to come out, x minus 2, plus 2 gets to come out, x minus 2. So we end up with the answer 5x squared plus 2, and then x minus 2. Okay? All right. Okay, so if it's got 2 terms, then you could be in one of 2 cases. You could have the difference of squares, or we could have the difference in sum of cubes. So let's do these two now. So the first one, difference of squares. I am hoping that this is familiar. Difference of squares. So I'm actually going to do a bunch of examples for the difference of squares because they are super easy. So x squared minus 9. So I call this the difference of squares because this is a perfect square. The square root of x squared is x, square root of 9 is 3. So that makes x plus 3, x minus 3. Okay, let's do 4x squared minus 25. So that's 2x plus 5, 2x minus 5. Let's do 9x squared minus 1. So square root of 9x squared is 3x, square root of 1 is 1. 3x plus 1, 3x minus 1. Okay, so you can kind of see the pattern. Now the cubes this is probably newer for us. And something that is also going to be new for you is that there is a sum of cubes and there is a difference of cubes. Now if you notice on the squares one, there's only a difference of squares. There's not a sum of squares. For the cubes, there is both that's allowed. So the sum of cubes, so sum means adding, is when we have a cubed plus b cubed. And so that's going to factor out to a plus b, a squared minus ab plus b squared. Whereas the difference of cubes is going to be, so it's a cubed minus b cubed. It's going to be a minus b, a squared plus ab plus b squared. Okay? Alright, now there's a saying for the cube rule that you can remember, and it's called SOAP. So SOAP stands for, write this down, I'm not going to write it down. S stands for same sign, O stands for opposite sign, AP stands for always positive. So what I mean by that is that if you notice these two rules, they go in the same order. You have an A, and you have a b, you have an a squared, an ab, and then a b squared. The only thing that's changing is the plus and the minus. So that's what SOAP tells you. This first thing is the same sign. So if this is a plus, this is a plus. The second thing is opposite sign. If this is a plus, this is a minus. And the last thing will always be positive. Okay? So this is new, I know. So let's do some examples. So let's do x cubed minus 8. So it's kind of similar to how you start off with the difference of squares, except now you're asking, is the perfect cube something? So can you take the cube root of x cubed? And yes, you can. It's just x. Can you take the cube root of 8? Yes, you can. It's 2, because 2 cubed is 8. Okay, so our rule. I like to put in one set of parentheses, the second set of parentheses. Okay, so same sign, opposite sign, always positive. So that's where the pluses and the minuses are going to go. Now we just have to worry about, am I going to put an x there or a 2 there? So here's the, well, that's for some, I'm sorry, we're here, but it really doesn't matter. Put the first thing here, the second thing, the first thing squared, the first times the second thing. So my first thing is x. It's going to go here, then it goes here and gets squared, and then it also goes here. Okay, and then the 2, that's the second thing, is going to go here, here, and here, squared. So here, here, and here, squared. Okay, and then let's just write it a little bit prettier. So, so x minus 2, x squared, plus 2x, plus 4. Okay, and if you are wondering about this 1, 2, 3 trinomial, this thing will never be factorable. So once you do this, you're always going to be done, which is kind of interesting. All right, let's do another example of our cube rule. So let's do x cubed plus 27. So you're going to have to memorize some cubes. Hopefully 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64 is reasonable at this point, and we'll try to increase those numbers as we go on. All right, so cube root of x cubed is x, and cube root of 27 is 3. And this is a sum. So put your binomial, put your trinomial. The same sign, SOAP. The opposite sign, the always positive. So that's how SOAP helped you. Okay, and this is why I really like to go ahead and write the x and the 3, because I just memorize. It goes first thing, second thing. First thing squared, first times second, second thing squared. Okay, so first thing here, second thing here, first thing squared, first times the second, and then second thing squared. Okay, and then we'll just rewrite it as x plus 3, x squared minus 3x plus 9. Alright, so let's do some examples on the next page. So since so many of these exponents are going to have to get memorized, here's just a quick exponent thing. You should know most of these. 2 to the first power is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the fifth is 32. At this point, all I'm doing, I mean, these aren't honestly memorized for me. I just say 32 times 2 more, so that's 64. Okay, 3 to the first power is 3. 3 squared is 9. Cubed is 27. Then 81. So this is 4. 4 squared is 16. Times 4 is 64. Times 4. I'm honestly not sure. Let's do it. So 6. 256. Okay. Alright, 5 to the first power is 5. 5 squared is 25. Cubed is 125. Yes. And then to the fourth is 625. Okay, 6 squared is 36. 7 squared is 49. 64. 9 squared is 81. 100. 121. And we'll be adding to that list as time goes on. Alright, so example 1. So this is mixing it all up. You're going to not just do one thing. There's going to be lots of things we can do. So first, always look for a GCF. Is there a GCF in these two terms? So yes, there is. They both have a 2, and they both have as high as x cubed. So then I've got an x left here and a minus 2 here. Okay, now check. Is there anything you can do left with the nomial? And there's not. X minus 2 is going to be as far as it goes. Alright. Next. Example 2. So, is there a GCF you can do before you start? So, there is. They both, or not both, all three go 2. Yeah, 14 is not divisible by 4, neither is 10. So 2 is as high as I can do. So 2x squared plus 7x plus 5. Okay? Now, this thing is probably going to factor, so you're going to have to do that. So for the time being, you're kind of just going to ignore this 2 that's on the outside. You factored it out. There's nothing left you can do. So what I'm going to do is I'm going to come down here and write my answer. And it has a 2. And then I'm probably going to have 2 more things here and here, okay? And I'm just going to completely ignore this 2 now. So now this is a 1, 2, 3 trinomial. So our steps were factor by grouping. First step, 2 times 5 is 10. What multiplies to 10, yet adds to 7. So I've got 1 and 10, 2 and 5. Those are the only options. 2 and 5 can add to 7 if they're both plus. So this is going to be 2x plus 5x instead. So I've still got 2x squared, and I've still got plus 5. Okay, now we can group. Take out 2 and x, x plus 1. Take out 5, x plus 1. This is our checking point, x plus 1, x plus 1. That's good. So I'm done. X plus 1 and 2x plus 5. Alright. Example 3, does it have a GCF? So this is divisible by 2. This is not. No highest x's, so no. This has 1, 2, 3, 4 terms, factor by grouping. So if you want to pause the video, go and see if you can do this. 2x squared, x minus 4, plus 9, x minus 4. 2x squared plus 9, x minus 4. Now we should probably check, does 2x squared plus 9 go any further? No, it does not. So that is final. Four x squared minus 81, a to the 4th. So no GCF, 4 and 81 don't have a GCF. This is x, this is a. So this has 2 terms. Your 2 terms options are difference of squares or sum of cubes or difference of cubes. So 4, is that a perfect square or a perfect cube? Okay, so it is a perfect square. What is the square root of 4x squared? So that's 2x. And what is the perfect square of 81, a to the 4th? It's 9a squared. So separate with a plus, separate with a minus. That's the only rule for difference of squares. So this is 2x plus 9a squared and 2x minus 9a squared. Okay, example 5. Now this is actually a cube one, right? Because I see cubes here. 8 is the cube or perfect cube of 2, so this is 2a, and this is 3b squared. Let me write that again. Alright, so the cube you want to set up with a binomial, then a trinomial. SOAP, same sign, opposite sign, always positive. Okay, and then I'm going to go through this. This is the first thing. This is the second thing. This is the first thing squared. First times the second. second thing squared. All right. So this is the first thing. This is the second thing. This is the first thing squared. You do have to square all of 2a, so I'm going to put it in parentheses. This is the first times the second. And then this is the second thing squared. 3b squared squared. Okay. Now we do need to simplify. There's nothing I can do here. Now here, 2a squared. So 2a times itself. 2a times 2a is 4a squared. Okay, now here, 2a times 3b squared. So 2 times 3 is 6, ab squared. I got a plus sign. Plus 3b squared squared. So that means 3b squared times 3b squared. If you need to write that out, 3b squared times itself, 3b squared. So that makes 9b to the 4th. And that's it. Okay, and then we actually did example 6 on the front. I didn't realize they had this one on the back. But we'll do it again. So this is a perfect cube. Cube root of x cubed is x. Cube root of 1 is 1. So if you want to try to pause this and do it again, you can. So plus, minus, plus. First thing, second thing. First thing squared. First times the second. Second thing squared. And then just for simplification, x squared minus x plus 1.